everybody. This is a video of why you would not want to solve this problem the right way and why you would want to just do the process of elimination technique that we did when we were solving this problem together in class. So I want to show you exactly what would be entailed in order for us to figure out what the velocities of each of the individual blocks are after the collision. So the first thing that we need to remember is that this is an elastic collision. So because it's elastic, both energy and momentum are conserved. Okay. So like we said before, in terms of the initial information that's provided to us, we know the initial velocity of both blocks and the initial velocity of and the initial mass of both blocks, but we don't know anything about what happens afterwards. So that means that we have two unknowns, right? So we have two unknowns, which is the final velocity for block X and then the final velocity for block Y. But using conservation of momentum alone won't help us figure this out because, like I mentioned, we would have one equation and two unknowns. So we need to use the kinetic energy, conservation of kinetic energy as well to be able to figure out both velocities, because then that way we have two equations and two unknowns. So let's set those equations up. So first let's do conservation of momentum. So my equation would look like this. The mass of block X times the initial velocity of block X plus the mass of block Y times the initial velocity of block Y, and that equals the final velocities of each one of these guys. That's final. Keep consistent. Okay. And then now let's set up our equation for conservation of energy. Right, so the kinetic energy from box X. So we'd have 1/2 mv initial squared plus 1/2 my v initial squared. Ooh, you guys can see really quickly how this is going to get really messy. So then you have to be really careful when we're doing a problem like this. So 1/2 mxv final x squared plus 1/2 my v final y squared. All right, so here are our two equations. These are the two equations that we're going to use in order to figure out what our final velocities are for both. So one cool thing is that the initial velocity for block Y is equal to 0, so then we can eliminate this over here, and then this term in this equation also goes to 0. And then we end up with this equation here. And then over here, we end up with this equation. Sorry, I'm writing a little fast here. Okay, so now here are the two terms that we're trying to find. So we have to substitute one equation into the other in order to figure out, in order to solve for one of these terms. So if we wanted to, I'm going to use a conservation of momentum energy to solve for and then plug in to this equation here out of simplicity. So let's solve for final velocity of y. So now let's do this. So since I'm choosing to solve for v final y, so now my equation will look like this. I'm bringing this term, subtracting on to the other side. So I have minus mx v final x. And then the last step I'm going to do is, since I'm solving for v of y, then I have to bring my mass divided over to this side here. I'm going to rewrite that just so it's clear that this is a y and not an x. And then now that we solved for my final velocity y, then we're going to plug all of this whole thing will get plugged into here, to this square. I'm not going to do that. You guys can see here how this got really messy really fast, because then this whole term here has to get squared. So it is possible for us to solve this problem using this method, but when you're solving multiple choice problems in the AP exam, you only have 2 minutes to solve each problem, right? So doing all of this algebra won't be helpful for you. So we have to be able to determine or recognize that I can just plug that the initial momentum has to equal my final momentum. And if I can figure out, I can determine what the initial momentum is here, but with the information provided. And then I can just solve for the final momentum of the different options that are given to us and then see which one matches and which one doesn't. So that would be the best way to approach solving a problem this way. All right, that's all from here. Any other questions? And we can just talk about this tomorrow.